started 18 years ago at Adobe. I'm sure it was a much different company than it is now. And you saw it grow like crazy, and you saw people love and hate Photoshop, I imagine, and all of that. Which part of Adobe are you in?
So I'm in the digital media. So I came through the Macromedia acquisition. So
Mhm.
Flash, Dreamweaver, and those products. But yeah, so I saw a lot of things. I mean, at the time we were still racking servers and having a lot of hardware, and so that transition to the cloud, which happened about 10 years ago now, was a big change, I think, for the company. Enabling a lot of teams to do a lot more. I mean, at the time you wanted to deploy a service, it took 18 months just to procure hardware and get all the pieces together, so definitely that acceleration was a significant change within the company.
Nice.
All right. Before getting into anything further on the technical side, can we? This is a question from my friend Miguel, who wanted me to ask you. Before we go too deep, can we just get a little bit of background about your local environment, tools, ID, terminal, etc.?
Personally, or in general? I mean,
let's say personally.
Yeah, so I mean, I'm on a Mac. Actually, I was on a PC for a long time. At some point, my boss was like, "Why don't you go to or a Mac instead?" When it was time to renew the computer, and I was like, "Okay, whatever." So I use mostly open source. I'm Atom guy, Git, Docker. I think everything I use is free. So maybe I should cost more to the company, but I don't. So it's mostly free stuff, and Docker. Everything that we use is.
So, just jumping in real fast, like when you were going from, like you talked about the migration to the cloud at Adobe, and how that took place, and you were on Mesos, and then you were moving towards Kubernetes, I imagine. And I know we talked with Mike and Joe about a month ago about that process and how Joe ended up being on the Kubernetes team, like 1.0 team release. And I'm just wondering, for you, how was it? How was the switch to Kubernetes, and what did that look like?
So it was, I think it was post Mesos. So I talk about we went to the cloud. I mean, all this thing took time, right? We, Adobe, at least the team I was involved with, went to the cloud. It was 10 years ago. It took maybe another 5 years before we got into containers. And I'm talking about production here. Everybody was playing with things as soon as they come out. So when we went to Mesos, I think Kubernetes 1.0 was already there, but we didn't feel maybe that it was ready for production at the time. I don't know if we necessarily trusted it, and I'm not saying it was a right decision. It's just it's the decision that we took. But at the same time, we definitely kept an eye on it. Our entire operation is based upon being able to change the piece should something new come up. So it's very modular in a sense. It's a hard thing to do. We call it changing an engine, in an airplane while it's in flight. But at the same time, it's an ability that we keep to ourselves. We want to be able to do it, and so we were definitely keeping a close eye on Kubernetes. But at the same time, learning about containers and how do you roll them out and how do you build images. I mean, you have to start from scratch, right? At the time, and so that journey, I think, took quite a bit of time. And so I'm not surprised that Joe, Mike, they were already playing with Kubernetes, even though we were maybe a little bit behind them. But I think we used their inputs. There was definitely a group focused on, hey, what are the criteria to move to Kubernetes? I remember at some point, and maybe we're jumping a little bit ahead. But it turns out we ended up writing a lot of custom components for Mesos, and one of the criteria, one of the reasons to go to Kubernetes is the community is so much bigger. Writing your own component is great because you can make it do what you want, but it's expensive at the same time. You still got to maintain it. You still got to keep up. And so we wanted to definitely leverage everything that the community had to offer and enhance it, and then contribute that back. And so one of the criteria, I remember, so we wrote all those custom components, and there was a laundry list of things. Hey, when we move to Kubernetes, what's going to happen to those components? Get rid of that component, get rid of that component, get rid of it. And I was like, what's going to happen to me? My component is going away. But it was just a shift in in mentality a little bit. Is, hey, let's let the community has probably already resolved the problem you're trying to solve. Let's leverage that, and let's if it doesn't work exactly, let's enhance it, and maybe somebody else can find it useful. Yeah,
that's pretty that's in line with the topic that we're talking about right now, right? Like this idea of, okay, well, Ingress was there, it was the community had that, so it was great, you were using it, but then you wanted to go into this like, now we got to figure out how we can make it better. How can we enhance it? And what are we going to do? What should we do? So just basic, still laying the foundation here. I would love to know about the whole networking side. Like, I understand networking and it's how computers talk to each other. It's very important with Kubernetes. But I'm wondering, can you give us a breakdown of Ingress? And I look at it as like the thing that is the front line. It's the front lines with the web, we could say, and then Ingress controllers, so that people know what we're talking about when we start to get a little bit deeper into this.
Sure. So I mean, for us, when we talk about Ingress, we talk about like you said, the front end, the web, the client. But it's as soon as that packet leaves. So let me back up. We have a pretty standard deployment: load balancer in front, and packets are routed to individual services. And so when we talk about Ingress, it's really, when a packet leaves the load balancer and all the way until you reach the namespace, in your Kubernetes, it's almost to the service. Maybe it can go all the way to the service. So that's what we think about Ingress. And so all this routing, when you think about in Kubernetes, what is a service? You have a service, you have endpoints. So that's the individual pods, right, that listen on some ports. And you want to forward traffic to them, from, actually multiple input points. That was one of our challenge, actually, is we had a multi-path Ingress. There's teams that want to expose the service publicly, teams that want to expose the service just internally, custom, just to some their customers only, so then, that was one of those challenge, I guess, when I think about limits. That's what I think about Ingress. And so there's two components at play here. You got the data plane. So that's essentially the reverse proxy. That's the thing that decides, hey, there's traffic, got to go to that service. And then there's the control plane. And that's typically what you think about when you talk about Ingress Controller, is what is that component that actually programs, that data plane. A lot of team talks about, they run Nginx. I think that's pretty, a familiar concept. You have a config file that has all those routing, and the controller, if you will, is just going to update that config file and tell Nginx to reload, and there you go. So the controller is not in the data path, at all. That's what we talk about.
Yeah, to take it a little bit further, just because, I've heard a lot of folks talking about there's a lot of love for Nginx, but then also people maybe going a little bit more towards Envoy. In terms of choosing the controller that works for you, what factors should people keep in mind, or what things do you think are important?
It's features, I think, and it turns out we were on Nginx with Mesos, and we went to Envoy, actually. And the community around Envoy is actually, super big. So I don't know if it's something that you follow. The way they're using it at Lyft is, at scale. I mean, it's a graduated CNCF project. It's got all those things that, it can do a lot. I mean, it's a Swiss Army knife of, Ingress and proxy, and even the way we're using it, I don't think we're scratching the surface on the capabilities that what that thing can do. And so, the Ingress controller, which is responsible for programming it, has, a lot of opinions, if you will, or only offers, configure a certain part of it. And this is where we reach some limits. So like I said earlier, we have a lot of teams. I mean, a lot of requirements, if you will, a lot of routing needs, more exotic than others. And Envoy can support those, but the controller may not necessarily support them. And so the question is, how do you, expose those? And how do you expose those? And I mean, I think, about that, when you talk about that question, I think that answers it. Is how do you choose? I think it's more about features and, and support and community around it.
Very good.
Yeah, and so like I understand that networking has its limitations, and still looking at this, I've heard from other friends that like what Kubernetes is based on in the IP tables are notoriously complex, right? And I wondered if you ever had any problems or have gone down that rabbit hole, and you could share some insight and wisdom with these IP tables that are leading to bottlenecks.
It is. I mean, when I think about that, it's not necessarily part of Ingress, although, it is part of my team's responsibility. So it's no secret a kubeproxy, native kubeproxy, use a lot of IP tables. And if you ever look at the IP table files, it's huge. I mean, it's big. And so, without advertising, we're leveraging a component that converts those to eBPF. And so, when you make that transition, and we haven't fully made the transition, we're kind of midway, so we use that component. We do a lot of eBPF with that component, but we're still using IP tables a little bit right now. But in my testing, those rules just go away, like the file's empty. And so if you think about all that parsing that has to happen every time a packet goes through the NIC, it's a lot. So if you can get rid of that, you're going to see performance improvements for sure. But eBPF, I love eBPF. I try to learn as much as I can. There's summits obviously tomorrow. It's free. I encourage everybody to sign up. But those are the experts. But to answer your question, I mean, IP tables is definitely can come up as a bottleneck, in high traffic deployments for sure.
Yeah, and just following along that line, is there anything else that's baked into Kubernetes that you enjoy or don't enjoy when it comes to networking?
Well, it's more general than that. It's the CRD, to me that was the game changer, I think, from Mesos to Kubernetes is, being able to create, those resources as, basically an API, if you will, and being able to extend them as opposed to, write a brand new component. And that's what we ended up doing is just extend the CRD. It's easy to do. You just, it's a YAML, you extend it, and then, you update your controller and just have whatever components that uses the CRD to, leverage that, that new information or new structure that you put in the CRD. And that applies, that's not just Ingress, that's anything. I watched the OpenEBS, I mean, it's the same concept, right? You got a controller, you got a data plane, and anything that you can extend based on that, is going to make your life easier. So to me, the CRD is the big thing for Kubernetes.
Nice.
And now that we got a little bit of groundwork established on Ingress and the current state of affairs, now that Ingress is at version 1, what do you think the future of Kubernetes with Ingress will be?
So there. I mean, if you look at the SIG, they're already making improvements on how do you leverage Ingress. In our environment, we actually use a different CRD, which is Ingress Route, which builds on top of Ingress. But I think those things converging. I think Ingress 1.0 or 0.1, it was very basic, right? You could route packets to services, but there's so much more that you need. So and as we're going to start talking about limits and it's all those routing needs. Is how do you? Yes, what do those team want to do? And I'm always kind of the guy, I hate to operate in the black box. Like I want my users to know what's going on, because I don't want to prevent innovation, if you will. I don't want to be so, it's like, what do you want to do? Tell me, and maybe we can talk through it. And if it's reasonable, we'll enable it. So that's kind of like my mode of operandi, if you will. But I think, Ingress is progressing, that, one of the challenge was all those annotation to make it do what you want to do, and managing annotations in Kubernetes is, it's kind of like a B plan, right? You don't leverage all the features that you get from CRD around validation and, all this thing that comes with it.
Well, let's dive into this whole limit, and when you hit the limit, what limit was it that you hit, and when did you realize that, hey, this is something that is happening, we should probably start looking for another option?
Correct. So, so we, I talked a little bit about normal limits, high limits, things that you get in storage, your disk has a fixed size. So we reach limits on the number of ingresses and number of services. We reach limits on long-lived connections. So, in an Ingress environment, if you have long polling connections, and we have some teams that use those, and you have to refresh the listener, we'll drain those connections. And, at some point, we're going to cut them off. We're not going to drain them forever. But it turns out there's some teams that want to have those long polling connections for days, weeks, I heard. Who knows, what they're doing. And so, how do you, address those needs? Another thing was around the churn. The churn is, for me, is, it's not so much the volume, but it's the volume per a time slice. So lots of changes in short amount of time. And that, creates some bottleneck on Envoy in the way it was configured. I think, so those are the normal limits that you would get. And then there's the challenges, we talked a little bit about that, multi-path, multi-tenancy, all those teams with all those needs. And maybe that's something we didn't talk about, is we operate in a multi-tenant environment.
Mm-hmm.
And so we have those constraints as well, as how do you secure that, so that, teams that, have nothing to do with each other, but they yet are deployed on the same cluster, have those security policies in place. And so, when you combine all those challenges and those limits, you find out that, well, your Ingress controller may not provide all the features that you need, or that, you have a little bit of a different opinion than what's implemented in the Ingress controller. And that's where you're like, okay, I got to do something.
So when you said, you came to and you were like, okay, let's do something. Now, what were some factors that you were looking at? Because I imagine cost was a huge one. You were saying, well, let's try and build it, or let's try and see if there's another company out there. I'm sure you did some due diligence to try and figure out, is there something else that does what we need it to do? And how did that whole process look?
So absolutely. So, I mentioned Kubernetes. We don't want to build things on our own. We from scratch like that. Those days, are over. Or so it seems. And so, we definitely did our due diligence. A lot of evaluations on what was out there. We, at that time, we knew Envoy. And we knew we were going to stick to Envoy, and that kind of, reduce the choice of Ingress controllers. And that's good. You got to have your constraints. And so at the same time, we knew that Envoy also were providing some of the features that we needed. They were just not exposed in the Ingress controller. And so at the beginning, we started enhancing, I mentioned enhancing the CRD, and then, making changes in the Ingress controller to support all the things that we needed. But we reached a point where that wasn't sufficient, and it was really around that churn. So much changes that would lock Envoy, and I don't know how deep we want to go in Envoy, but they support multiple APIs to being able to configure Envoy. And so the controller that we're using is using one generation of those API, which is kind of like the state of the world. So every time things change, the whole thing gets sent to Envoy, and you can think, it's a lot of data when you talk about at scale. But Envoy supports, Delta changes, so only send the change, and so those, that's one of the factors that I said, okay, we need a controller that supports this, and so, does that exist? And well, it turned out it didn't. And that's where we were able to sell that, higher up, is that we could, we needed to write our own at that point.
Yeah,
but I gotta say, it is the last resort, right? It's like you don't want to do that systematically, for sure. And
you sound like you're talking from experience. You've
felt that pain.
Yeah, you've done it a few times, and you realize how much more difficult it is, I imagine, than just hopping on to another community that has already done it.
Exactly. I mean, yeah, that's where you leverage what the community has done. And once you build something from scratch, it's yours. Like you gotta keep it. You gotta keep it up. This is it. Security, update, maintenance, the whole thing. And that's where you talk about the long-term costs, I guess. And in most cases, it's the community will resolve those things for you. And so that's something that we want to watch. And so, while we're doing that, we're still watching what's going on out there. We may contribute this actually back to the community ourselves.
Yeah, that was my next question. I was wondering if you've thought about open sourcing it so that you have others that are helping you.
We definitely, that's our plan right now. So we're in the midst of building this replacement, but the plan is to open source it, see if it can help somebody else, and get the feedback that you normally need by building those kind of components. But yeah, that's the plan eventually.
And so, just diving into how things are structured at Adobe a little bit, because I know Joe and Mike were talking about these loosely coupled teams, but I'm wondering how do the environments look? Do you use an environment for each team, or is it a cluster for each team, or is it divided into projects? How does that look?
It's up to the team to decide what they want to do. Our role is to maybe unify the building of those infrastructure so that no two teams have to build the same thing differently. That's, I think, a cost to Adobe that we want to avoid. I think about deployment. There's a million ways to deploy, right? The team that we're talking about here, they're providing value to Adobe customers. Those customers don't care how things are deployed. We want those teams to focus on that business value that they add, right? And so we don't want them to spend time on trying to figure out how to deploy. We don't want them to figure out how do you get your thing compliant to some, standards or whatever. So we want to unify those kind of things. So the way it's structured is we run services, we deploy services for other teams at Adobe, but we operate a little bit in an open source model within the company. So our infrastructure code, if you will, is open. People can make contribution. People can run it. We run a set of clusters for teams that don't, want to run their own services. So it's a blend of kind of it all in a sense.
So yeah, however someone wants to do it, they can. And the main question for me is, how do you keep the communication so that people aren't building the same thing twice? How does that happen? Because is it every time that I want to go out and create something, I should check with the whole company to make sure that it's not already built?
Well, in my experience, there's no mandate. Teams actually could do that. And if you think about Adobe, it's not, we don't have one product. We don't have one customer. It's hundreds. It's acquisitions. It's services that sometimes have nothing to do with each other. Although there is a push to kind of unify those services, use like the same identity, and there is some integration, if you will. But at the end of the day, I feel the engineering managers have that freedom. And so, I think it's on us to say, hey, you want to do this? We already done it. Look, if it doesn't meet the needs that you have, well, contribute to it. Some other team out there may need what you need. And so that's how you kind of give back internally. It's the same concept as, the Kubernetes community or any other communities out there, I think. is, try to leverage work that somebody else already has done. So you don't reinvent the wheel.
You're making sure that everyone that there's no overlap, that if someone has the same infrastructure or the same whatever they need as someone on the other side of the company and they don't talk, you're the go-between and you say, hey, well, maybe these are a bit redundant. We can form them into one.
We do some of this outreach, I think, but at the end of the day, it comes down to when you build something, it's got to have all those standards. Like you take credit cards, got to have, this compliance, got to have, so that work, if you have to do it yourself, from scratch is very expensive and takes a lot of time. And that means you're not going to ship your product, until you pass all those checks. And so if we can provide a way to build, an infrastructure that already has those checks in place, yet you can stand it up yourself, you're going to save teams a lot of time and money. I think, and to the company, you're going to save, the company a lot of time and money because, you remove that duplication of work. And so that's what we're essentially trying to do, I think, with
that's awesome
platform. And I mean, I think it's common in the industry. It's like you want to remove redundant work, especially a company so large with, like you said, teams that don't know. I mean, when I joined, there was 5,000 employees. We're at 20,000+ now, and so there's people you don't know. There's teams you don't know, and you don't know what they're doing. And and if it's an acquisition, they already have something in production running. And so you can tell them, shut it down, and this is what you got to use.
And in terms of that, and some of the pain points that you've identified, and also creating a culture of contributing to solutions actively, what are some of the biggest struggles that your users have for Ingress communication into the Kubernetes clusters?
I'd call them exotic routing needs, maybe.
That's a nice term.
That's a nice. You could patent that, exotic routing needs. I'm gonna write that.
I mean, the right word would be requirements. It's like, hey, I want to be able to route based on some header or some path on some user agent on some whatever IP address. I don't know. It's whatever. I don't know.
But also, as you said, when dealing with an organization so vast, that's why you will naturally encounter some of those more exotic.
Exactly. Yeah. The more teams you need, you deal with, the more of those various requirements you get. And they're all different. But at the same time, you want to provide value. You want to support them. You want to help them. And so, but you're right. I mean, it's because of the diversity of teams that you get into this this situation.
And because of that, maybe some of the best practices, or maybe like you said, maybe they are really just exotic, unique sort of special cases, but it's sort of anticipating maybe some of these issues. Are there some things that people could keep in mind?
Well, normal stuff. I think one team asks for something. It's a maybe. Another team asks for it. That's the trigger, I think. So it's pretty mathematical. But I mean, I think it's all it's the business requirements. Like if I can't offer exactly what they want, do I have an alternative? I'm not gonna live hanging. I mean, I'm not gonna say no, and I know what they're gonna do. If you say no, they're going to go and stand up their own, environments, and they're going to do they're going to repeat this whole thing. And so we get back into that conversation we just had on, hey, we're going to rebuild, they're going to rebuild, what we already did. And so, and we don't want that, and the company doesn't want that. And so, I think, in most cases, it's reasonable stuff, and it's exotic because you didn't know, you didn't anticipate, it's the unknown kind of situation, but it doesn't mean it's unreasonable.
So I'm wondering about this, like Ingress, is it a love or hate relationship that you have with it? Because I was reading on some Twitter feeds between Brendan Burns and Tim Hawken, and Tim was saying like the best thing Ingress has for it is momentum, and that's it. Or the only thing that Ingress has going for it is momentum. And so I'm wondering how you feel about Ingress and the controllers and that whole way of doing things. It for you, is it fine? Is it all right, or is it there a better way?
That's a good question. I like it. I love it. It's it. The reason for that is because it allows team to, at the end of the day, do exactly what they want to do, and that flexibility for me is very attractive. And when you enable that, I mean, there's that sense of accomplishment. Like if you can't do this, if you can do Ingress, customers can't access the service that those teams build. And so when you open that up, you open, it's like the Pandora's box. You open, you enable the service. If that doesn't work, there's, basically no reason for being, well, it is not usable. And so, yeah, I agree. The momentum and, is true. So and the way it is done with the Ingress controllers and the separation of the data plane, the control plane, and all this stuff, I think is a model that, I like. Because you have two components that serve two different needs. They're tightly integrated, obviously. But when you focus on the Ingress controller, one thing that we say, it doesn't have to be up. It can't be down for a long period of time, but like running one of them is fine, as long as if it crashes or if the host goes away, a new one comes back very quickly. That's fine. You're not in the data path, and so I like that separation of duties for sure. It's more microservice-y in a sense.
So like when you were creating your own, and you were saying you were using Envoy, and did you just add on to what Envoy already had and like personalize that, or did you create something from scratch?
No, we didn't create something from scratch. We added. So let me to back up. We extended the Ingress controller, so that was an extension. In Envoy, we added things that were missing or that we needed. But at the end of the day, it's still the same Envoy, the base code that's running. And I think, for me, I think one of the things we haven't talked about is, access logs. I actually worked on something to be able to give our users access to the logs for their namespace, which, in a multi-tenant environment is not, you can give them access to the entire logs, but they only want to see their own thing. In that case, we create a brand new CRD from scratch, and that's an extension. We use FluentBit, and that's an extension to FluentBit. So we kind of did it all. There's extension of the CRD, there's updating the software, and there's creating a new one. But I think if I would take one thing away from this talk is from this conversation is being able to run a customized copy of the component that you have is something that is good. Doesn't mean you should do it in production. It's being able to do it, because when you have an issue, being able to make that change and test that quickly to see if it addresses your issue, it's going to help you resolve those things better. So knowing how to build those components, knowing how to deploy them on your own. And again, it doesn't mean that you would run, those custom copies on your own or your own production. It's just the ability and the know-how that is, to me, critical, I think, to being able to address those issues.
That's great wisdom. That's super helpful.
And I think just to continue with that as well, is that, when I first started checking out things about Ingress, the things that I got a hold of were stuff about space probes and about a guy who went to test his technology with Ingress in cyber cafes, in internet cafes in Cambodia. So we start with these sort of really, really complex notions that seem totally like unfathomable and really, really difficult to grasp. But just, listening to you kind of hash these things out and talk about them in a really practical way, I'm just kind of curious, when you have to explain what you do for a living to people, how do you synthesize that?
Well, I mean, I'm a software guy. You know, I don't pretend to be a, you know, a network engineer like in the old, you know, definition. You know, I don't work on switches and routers. But at the end of the day, we're still routing packets. But you know, I'm still a software guy. So that's the way I explained it. And Ingress is the place I'm focused on. You know, in my previous role with Mesos, I was working on scaling. So I'm not, you know, that's the beauty about networking with Kubernetes, is that it is software. I mean, you got to understand, you know, obviously, you know, everything that you talk about, Bart, you know, around the, you know, the routing and all that. But it is software, and I'm a software guy. And so, you know, at the end of the day, you want to solve problems with software.
Yeah. And as you said earlier as well, too, a lot of it, what it's about is enabling people, giving them more freedom to be able to do things. So this might sound like a bit of a stretch, but Laurent, I think we can call you a freedom fighter.
There we go.
I'll take that.
I'm a fan. I'm a fan.
I was not expecting to hear that today.
But you're welcome. You're welcome. You're welcome.
That is awesome. All right. So Laurent, the freedom fighter, do you have an idea of like how many nodes is too many? And this one was something that, you know, I've heard people debate, like after 500 nodes, it starts to get a little bit hairy, but then others say like, no, if you're running it correctly and you are mindful of the services, then you can go up to 15,000. Is there for you an idea of too many or not enough, or do you not even think about that because you architected in a different way?
So I don't know if I think about that or just only that. You know, you can, you know, 500 nodes with one service on the nodes, you know, is going to be just fine. 10,000 node with one service. So it's not just that one, you know, metric or criteria, I think, that matters. It's the combination of it all. It's how many, you know, 100 million services on one node, it's not going to be good, you know. And so if you know, you gotta, I think it's around the architecture and understanding, you know, how all those limits kind of work together. And you know, and that's another thing is, you know, we talk about measuring and, you know, measure everything, and limits are good. I think that's why you have limits. Is, you know, it doesn't mean that you know what the limit is, but you know that, you know, you put a limit, and when you reach it, well, this, maybe you got to take action. Maybe your limit was too low. You know, I remember having a conversation, you know, at reInvent, actually, with some of the Amazon networking guys, and they had, you know, Amazon, they have limits everywhere. Like, you know, everything is a limit. And, you know, I remember someone asking, why so much, you know, so many limits? Like, why are you limiting the number of security groups you can have in, you know, and the answer was, limits are good. You know, you don't know how people are going to use your software. And so, you know, when you put limits and you know, you kind of alert, or you kind of figure out when those limits are reached, this is when you realize, okay, you know, maybe this was used in a different manner that was expected. Maybe, you know, I architected the right way. It's kind of like, it's preemption. You know, it's not reactive at all. It's, you know, being able to, you know, say, hey, I think this works great with that limit, and so I'm just going to put it there. And when I reach it, I mean, I gotta, you know, refocus, maybe make some changes, maybe not. And so, you know, that's where I realized, well, limits are good. You know, I mean, they're a pain in the butt when you're a customer, but you know, they're great when you know, when you design something, and, you know, especially when it's used in a manner that you didn't expect.
That's such nice insight to think about. Yeah, limits are great because you don't know how your tool or your software is going to be used. So better to be safe than sorry and figure it out. If there is something that is being used how it wasn't intended to be using, you can make sure to nip it at the bud and not let it go.
Yeah, or adjust, you know, maybe this is the direction. I mean, you know, when you look at all the software and all the components out there, how many of them are actually used in the way that were intended in the first place? You know, I mean, you got to adapt. I think that's what limits give you, especially if you can raise those limits easily. But, you know, this is the indication that, hey, you know, maybe there's something there, you know, or you can provide more. or you can do something different.
That's awesome. Great insight there. I like that a lot. Now, you said, okay, you don't look at it only as the nodes and what is the limit for the nodes, because you have to factor in many different pieces. What are some of the other factors that you look at?
Bin packing, number of pods per node, number of, we talked a little bit about IP tables, and those are used for policies. Number of policies, they all affect routing, and that affect actually ingress and egress. I think the underlying VM and what it can support, both in terms of networking, and CPU and all, just the usual characteristics, I guess. It's a combination of them all, and that's why it's a hard thing to do. Like there's no one metric say limit rich, got to do something. It's it's the sum of all the parts, I guess. And that's why it's hard to know what to measure. But I think that's a hard thing to do. But that's something you need to do.
So just the last question along these lines, and then I'll stop with it. But I'm wondering, like, how do you reconcile with which services you're going to run on different in this? Like, if I'm saying, okay, I have a limit, or I don't have a limit of services, how do you see which ones are worth running and which ones not? Or is that not a question either?
I don't know if that's a question. I mean, it's
okay.
I mean, it's the behavior of the component, and is it meeting your needs, and do you know what it's doing, and is that is it being used in the way it was supposed to be used, and it's knowing this, and knowing how it's built, how it works. So it's the internals and the externals combined. So I don't know if I answered the question, because I mean it's hard. It's hard, right? I mean, there's so much you don't know. But from what you do know, that's your entry point. That's what you got to leverage. But you got to realize that there's things you don't know, and you got to be ready for it.
Awesome. That's so good. So that's the
limit. That's the limit of the limits question.
That's the limit.
We've reached the limit. Limits are good, as you said. Now, this is a bit of a long shot, but it was stated that you are a major soccer fan. All right. We are, first of all, you can tell us a little bit about your experience with that, but this is a bit of a challenge. All right. Are there any ways that you can relate the evolution of soccer, right, to we could say perhaps the evolution of technology, networking, the things that we've been talking about? Like I said, if it sounds a little bit tricky, you feel free. We can deflect to Dimitri and he can give his answer. But just curious what you might have to say about that.
No, I love the addition of the technology in the sport. I think for me, the goal line, VAR to an extent. I don't necessarily like the way it's being used, but I like that it's there. I'm more on the opinion that the guy behind the computer should be the expert, and the guy on the field could be a robot, and tell them, or both. I think it takes away from the flow. But I think technology is there. It's in our lives, and so it's just natural that it goes into soccer. I'm an amateur. I'm not gonna have VAR.
Yeah.
I'm not gonna say, the ball crossed the line and that's a goal.
Or someone got elbowed.
Offside.
Yeah.
That was an elbow.
Yeah, you can play that to your advantage. I understand it's a question of but as you said, it's only natural that there's more of an introduction to technology in sports. Although some people do find it kind of frustrating as a growing pain.
It is. Yeah, you're right.
Yeah, but in terms of what it is allowing in terms of data analysis, the training aspects, tons of different things there. Obviously, I think there are a lot of benefits that people would agree with. And can you just tell us who your favorite team is so we know who to support?
There's only one. I'm from Marseille, and so it's Olympique Marseille.
All right.
Only French team to win the championship. Paris still trying. We'll see what they do this year.
There we go. So there have been some very insightful pieces of wisdom from you. One around soccer and the other around being able to run a customized copy of the components that you have, I think was one that you said. And I wanted to just dive in on that and make sure that I understood it correctly. Because you said, if there's one thing that you can take away from this talk, it is that being able to run a customized copy of the components you have is very important. Is that correct, or did I misunderstand?
It's correct. I probably would have phrased it a different way. It's about knowing how to build that component with, and customize it if you need, but mostly know how to build it. Can you actually compile Envoy?
You said being able to build it, having access to that, the capacity to be able to do that.
Right, and knowing how it's deployed, so, and again, it's really to help, if you run into an issue that maybe, the Envoy team doesn't know about, or any component. I mean, it's not necessarily Envoy, right? It's any of those components that you use, in Kubernetes could be the cluster autoscaler and all those kind of things. Can you add some debug statements and build it, deploy in your test environment, and that ability, that flexibility, will help, I think, and again, I'm not advocating that you should run a custom copy. I'm saying that you should know how to build it, and you should know how to do it. It's kind of like, those disaster recovery exercises. It's part of the exercise.
Yeah.
And that can help, I think, with, stability and quality of service.
And it's funny you say that, because Alexander, or Mr. Perconi, was on here like 3 or 4 weeks ago, and he was talking. He has a Russian accent, and it was scary listening to him say, I don't like it when people use the GitHub issues as like a support channel. It was in his Russian accent, like, go figure it out. Like, I'm not the support, I'm just building this. I'm trying to maintain this operator. And I think it goes along those lines. Like, being able to know how to build it, you will have a much easier time if something does go wrong.
Exactly.
And you have problems, and you won't have to hit up people for support on the open source.
That's issues. Community, right? You're not paying. No one's paying this guy. And now you're getting. I've seen those issues on GitHub. It's not working. Like, well, that's working for a lot of people.
Exactly. It works for a lot of other people. So maybe it's not you, or maybe it is you. And so the last thing that I will say is limits are good, as you put there. I'm going to quote you on that. Even though you didn't say it, it was the Amazon guys, but you made it famous here today. And I think we've reached our limit of this talk.
Awesome.
How many more limits jokes can we make?
As long as you know what your limit is, that's good.
There it is.
I think I'm going to go listen to Take It to the Limit.
We're going to have that as the fade out song right now.
That'll be the soundtrack.
Watch this on YouTube. So thank you, Laurent. Thank you for everybody that was here with us, joining us. And if you are not in it already, feel free to jump into Slack. We have a Slack community that is going off right now, and Laurent is in it. He is completely involved. I will put a link to that in the chat right now. But as for the rest, I don't know if anyone else has anything they want to say. Feel free to chime in now. I guess that's it.
Thank you, guys. That was awesome. I had a good time.
Thank you so much, Laurent. Fantastic.
Thank you. We'll see you all later.
See you later.
Take care. Bye-bye.